All right, let's talk about trigonometric identities. If you've ever felt like they're just this random list of formulas you have to memorize for a test, you're gonna want to stick around. We're about to show you how they're not random at all. In fact, they're a super powerful and logical toolkit for solving some pretty tricky problems.
But before we dive into the proofs and all the math, let's just take a step back and ask, why does this stuff even matter? Because really, trigonometry isn't just some abstract concept in a textbook. It's the invisible architecture behind so many amazing things in our daily lives. Take music, for instance. All those incredible sounds and chords in your favorite songs, they're literally created and fine-tuned using sine waves. Music directors can digitally shape these waves, which come straight from trigonometry, to get the exact note and sound they're looking for.
Or what about video games? When a character in a game makes a jump, they don't just go straight up and straight down, right? No, they move in this smooth, curved path. Well, that perfect arc is calculated using trig functions to make the whole thing look natural and believable. It's also absolutely critical in aviation. A pilot can't just point the plane where they want to go. They have to deal with the wind. So they use trigonometry to calculate precisely how to adjust their heading and speed to counteract that wind, making sure they land safely and, on time.
And this is nothing new. For thousands of years, astronomers have been using these exact same principles. Trigonometry is how we calculate the just mind-boggling distances between planets and stars, all from our little vantage point here on Earth.
Okay, so let's get into it. To really, truly understand trig identities, we've got to start with something you probably already know by heart, the Pythagorean theorem. It's the bedrock, the absolute foundation for the most important identity in all of trigonometry.
Yeah, you've known this forever, right? A squared plus b squared equals c squared for any right-angled triangle. But here's the cool part you might not know. This simple rule about shapes is actually the secret origin story of our very first trigonometric identity.
Now, just watch how beautifully this unfolds. We start with the theorem, then we do one simple thing. We divide every single part of it by the hypotenuse squared. And what does that leave us with? Well, we're left with the definitions of sine, that's opposite over hypotenuse, and cosine, which is adjacent over hypotenuse. And boom. Just like that, we've derived our first identity.
I mean, how cool is that? It's the perfect illustration of the deep connection between the geometry of triangles and these trig functions. And this equation, sine squared theta plus cosine squared theta equals 1, is true for any angle you can think of. That makes it an incredibly powerful and reliable tool.
So now that we have our cornerstone, let's start building out the rest of our problem-solving toolkit. See, there are a few different types of identities, and each one has a really specific job to do.
We can basically group them like this. The Pythagorean ones, as we saw, are all about relating the squares of functions. Then you've got reciprocal and quotient identities, which are great for rewriting things in terms of other functions. And finally, sum and difference identities. They help us figure out angles that aren't the standard ones we've all memorized.
Okay, these right here, these are the heavy lifters. They're the workhorses of trigonometry. And those other two Pythagorean identities, they actually come straight from the first one we derived. Knowing these lets you take some big, messy expression and just substitute, rearrange, and simplify it down into something way, way easier to handle.
Okay, theory is great and all, but let's actually put this stuff to work. We're going to walk through an example because seeing it in action is where it all really starts to click.
So let's say you're looking at this problem on a test. Secant x minus cosine x. At first glance, it doesn't really look like there's much you can do with it. But using our new toolkit, we can totally break this down, piece by piece.
Okay, so here's a great pro tip. When in doubt, try to get everything in terms of sine and cosine. It's almost always a good first move. So here, we can use a reciprocal identity to rewrite secant as 1 over cosine. That's a nice, simple first step that makes this problem feel a lot less scary.
Now, we just fall back on some basic algebra. To subtract these two things, we need a common denominator, right? So this little bit of algebra transforms our expression into 1 minus cosine squared x, all sitting on top of cosine x.
Now this is the fun part. That numerator, 1 minus cosine squared x, that should set off a little alarm bell in your head. Because if you just rearrange our main Pythagorean identity, you'll see that it's exactly the same as sine squared x. Making that substitution is the absolute key to solving this.
And for the final move, we can split up that sine squared on top into sine times sine. Now, why would we do that? Well, because it lets us pull out that little fraction, sine x over cosine x, And we know from our quotient identity that that's just tangent x. And there you have it. We took that kind of messy expression and boiled it down to a super clean, simple answer. Now, using these tools is incredibly powerful, but you got to be careful. Let's talk about one of the most common traps that students fall into when they're solving trig equations.
So here's the deal. You see an equation like sine squared equals sine. It is so tempting to just divide both sides by sine theta to simplify it. But please don't do it. If you do that, you've just thrown away an entire set of correct answers. The right way to do it is to get everything on one side and then factor. That way, you keep all the possible solutions.
The math educator Brian McLogan says it perfectly. When you divide, you can accidentally turn a quadratic into a linear equation, and when you do that, you're literally throwing away a correct answer. Always factor instead.
Okay, let's zoom out one last time and connect all these rules back to the real world. Because these identities, they aren't just clever tricks for your math homework. They're actually describing the fundamental patterns of the universe.
All of these relationships we've been playing with, they're all defined on the unit circle. And as a point travels around that circle, its coordinates trace out those perfect sine and cosine waves. Those waves are the mathematical language we use to model everything that moves in cycles, from sound and light to radio signals and the electricity in your walls.
So next time you're working with these identities, just remember, you're not just solving for x. You are learning the language that describes the rhythm of the entire universe, from the tiniest quantum particles to the largest galaxies. It's all about cycles and waves. Mastering this toolkit doesn't just help you pass a test. It gives you a completely new way to see the world around you.